Hi guys, today we are going to continue for week 2 lessons. In week 2, we are going to cover about the bioreactor or fermenter used during industrial fermentation as well as the production of chemical in industrial. Firstly, we are going to look the difference between bioreactor and fermenter. Basically, each biofermenter or bioreactor has a same standard component as you can see in the picture. Each one has a motor, a feed area, cooling jacket, baffle, agitator, and also a component which you can withdraw the products that already been produced during the fermentation. The motor will control the speed of the agitator inside the tank. The function of agitator is to ensure the evenly distribution of the nutrient inside the medium as well as evenly distribution of oxygen inside the tank. Meanwhile, feed area will be the place where you want to insert or to add freshly medium, or you want to add any pH buffer to adjust the parameter of the medium. Besides that, cooling jacket and buffer will act as a controller to ensure the temperature inside the tank is in the optimum temperature. For fermenter and bioreactor, the difference is if you want to produce or if you want to get the product that is an acidic condition such as organic acid, the equipment that's suitable for this kind of product is bioreactor. However, fermenter is more suitable for other than organic based product. Before we can start the fermentation, as you already learned before, there are two main processes involved, which are upstream and also downstream. Upstream basically is the preparation involved before we can proceed with the fermentation. The upstream process are producer of microorganism or the production of pure active culture, the formulation of fermentation media, and fermentation process. These processes are the upstream procedure that you must do before you can start the fermentation. Besides that, the sterilization of equipment also belongs under upstream process. After all the upstream process already been completed, we can transfer all the medium together with the pure culture or pure strain culture inside the fermenter or bioreactor tank, and we can start the process of fermentation. Each of the fermentation will have a different period of time with different parameter according to what kind of product you are desired to have and also what kind of microorganism that you are using on that particular time. After the fermentation is completed, now we are going for downstream processes, which is we are going to withdraw the product that already been produced during the fermentation. Under downstream process, we have several processes involved such as cell harvesting, cell destruction, and also product purification. At the end of the process, we must produce a product that reach 90% and above purity. Okay, now we are going to see what are the three operating systems that mainly used for industrial fermentation. There are three types of operating system. The first one is batch fermentation, second one is continuous fermentation, and last one is fed batch fermentation. For batch fermentation, this is the simplest type of fermentation and mostly used in the industrial. Why we say this is the simplest fermentation? This is because for batch fermentation, we only need to prepare the active pure culture. We need to prepare the formulation medium for the microorganism. We need to sterilize all the equipment required for this fermentation process. All the processes completed, then we can transfer into the tank and we can start the fermentation process. During the fermentation process, we are not going to disturb or interrupt the process by adding a fresh nutrient or by adjusting the environment of the medium. We will let it ferment by themselves until it completed. This is what we call as a closed system, whereby we don't disturb or we don't interrupt the process of fermentation. Since this is a closed system, batch fermentation also known as a dynamic state. Why we call it a dynamic state? Because the pH and also the parameter of the fermentation medium will undergo a fluctuate environment or fluctuate parameter. That means the pH will drop and also there will be an accumulation of the fermentation byproduct and also fermentation metabolite. There are some critical parameters that need to be taken under consideration, such as gas exchange of the balance between respiration rate and also oxygen transfer. As I said just now, batch fermentation is the simplest one because there is no additional feed that will be inserted after the inoculation of the pure culture strain. The example of batch fermentation is for product that belongs under secondary metabolite. Why batch fermentation is suitable for secondary metabolite? This is because we are allowing the microorganism to undergo all the four phases of growth. They are lag, log, stationary, and death phase. How can the microorganism undergo all the four phases? This is because under batch fermentation, we do not interrupt or we do not disturb the fermentation by doing the adjustment towards the environment, such as adding new nutrient or adding the buffer to adjust the pH. We will let the fermentation process occur without any interruption. Hence, it will allow the microorganism to undergo all the four phases until the last phase. Since the microorganism can undergo all four phases, hence batch fermentation is really suitable for secondary metabolite production. Let's see what is actually happening during each phase. The first phase we call as a lag phase. Basically, lag phase is also known as an adaptation phase, whereby the microorganism will adapt to the new environment from the subculturing process that has been done before. There are few factors that affecting the period of time for lag phase. Under lag phase, there is no microbial population. That means there is no increasing in the number of microorganisms. However, the size of the microorganism will increase. And under this phase, period of intense metabolic activity and also metabolically active. There are some factors that influencing the shortest or the longest period for lag phase. The first one is the chemical composition. If you want to shorten the lag phase, you need to use the same chemical composition and the same carbon source from the previous medium that you already used. This is because if you are using a different kind of chemical composition as well as different carbon source, the microorganism will take a longer time to adjust themselves to the new environment, such as new nutrient available, new temperature, new humidity, as well as new moisture. So, in order for us to shorten the lag phase, mostly industry will use the same medium as the previous medium. Factor number 3 is age of inoculum. If you want to shorten the lag phase, you need to use the age of inoculum that we are considered as young. What is the definition of young inoculum? Young inoculum basically is the inoculum that grows between 16 to 24 hours, because during this time the microorganism already enter the log phase, and microorganism that already entered the log phase, basically their metabolism or their metabolic activity is in the highest rate. Hence, it will shorten up your lag phase. Next is the high concentration of inoculum. High concentration of inoculum will shorten the lag phase by increasing the activity of microorganism. What is the meaning of high concentration? High concentration means if you are using the microorganism that falls under 10 power of 1 or 10 power of 2 in comparison with 10 power of 5 or 10 power of 6, which is the concentration is lesser. So if you want to shorten up the lag phase, we need to use the inoculum or the pure culture strain that falls under 10 power of 1 or 10 power of 2 concentration. The next factor is viability and morphology. Since we couldn't determine the cell whether it's still alive or already dead, it is very important for you to choose the correct growth of phase before you can inoculate into the medium. So, if you are using the inoculum that belongs to log phase, definitely the viability of the cell is higher compared if you are using the cell that belongs to the stationary phase or worse, the death phase, because the viable cell will increase the activity of microorganism. Once the cell already adapted or adjusted themselves with the new environment, they will entering the second phase, which is log phase or exponential phase. Under this phase, the cell will start to divide constantly until it reaches the maximum growth rate. If you still remember, for the log phase, since you can see the exponential growth of the microorganism, this exponential growth is affected by their generation time. If you still remember, generation time means the amount of time that required by a microorganism to double themselves. Each microorganism will have a different generation time. For example, E. coli will double up themselves every 20 minutes. So that means every 20 minutes, E. coli will double up themselves from 1 into 2, from 2 into 4, 4 into 8, 8 into 16, and so on. Since the generation time is fixed and is uniform, that's why you can say the graph under log phase is in exponential style. Besides that, the cell biomass also increase at constant rate. and under log phase, metabolic rate is in the highest rate. Meanwhile, after all the nutrients inside the medium is starting to deplete, then the cell will enter the third phase, which is stationary phase. Under stationary phase, the growth rate will continue decelerating until substrate completely depleted. The cell will start to die once the nutrient inside the medium starting to deplete. And once the nutrients start to deplete, there will be a competition between each of the cells. The stronger cell will have more nutrient compared to the weakest one. Hence, the weakest one will start to die. Under stationary phase, the number of death cells is equilibrium with the number of live cells. Hence, you can see the stagnant pattern for the graph. Microorganisms are still metabolizing intracellular storage compounds, utilizing nutrients from liar cells and produce secondary metabolite. So, for secondary metabolite, they are produced under stationary phase. Meanwhile, primary metabolite is produced under exponential phase. And once the number of the dead cell is more than the number of the live cell, the cell will enter the last phase of growth, which is the death phase. Under the death phase, cells die at a constant rate and each of the cells will undergo lysis. Lysis means the cell will burst and will release all the intracellular component into the medium. Okay, so as a wrap up for batch fermentation, in a keyword, batch fermentation is an operating system that will allow the cell to undergo all the 4 phases of growth. Besides that, batch fermentation also known as a closed system because during the fermentation process occurred, there is no addition of nutrients or pH buffer until the fermentation is completed. And since there is no interruption during the fermentation, each of the cells under batch fermentation will have a dynamic state. That means the parameter of the fermentation will undergo a fluctuate process. That means the pH will decrease, the accumulation of the metabolite, and also the accumulation of toxin inside the medium. And last one, batch fermentation is an operating system that's suitable for secondary metabolite. Example of secondary metabolites such as antibiotics, such as pigment, toxin, and also other pharmaceutical bioactive compound. Okay, now we are going to the second operating system. Second operating system called as a continuous fermentation. Under continuous fermentation, fresh media is continuously added and bioreactor fluid level is continuously maintained. In contrast with batch fermentation would not have any interruption or would not have any additional of medium. Meanwhile, continuous fermentation will have the interruption. That means we will insert or we will add fresh medium inside the fermented tank during the process of fermentation. This is what we call as an open system. Under continuous fermentation, each amount of fresh medium that already inserted into the tank, the same amount will be withdrawn from the tank. That means if you insert 1 liter of fresh medium into the fermented tank, you need to withdraw 1 liter from the previous medium. Why you need to withdraw the same amount? Because we want to avoid overflow from the tank. Because overflow will disrupt or will disturb the optimum level of volume inside the tank. Hence, will interrupt the process of fermentation. Under continuous fermentation, we can prolong the exponential phase, and it is more productive compared to batch fermentation because we can prolong the process of fermentation as long as we want. And in order for us to prolong the fermentation, we need to continue adding the fresh medium inside the tank. Under continuous fermentation, the suitable product that can use for continuous fermentation is the product produced under primary metabolite, such as alcohol, such as amino acid, and so on. Since we are adding a new medium inside the tank, it is very crucial for us to ensure that the microorganism is still remain inside the tank. Why we said it is crucial for us to ensure the cell to remain inside the tank? This is because we are continue to add on a fresh medium at interval time. The meaning of interval time is you will add the medium at a constant and uniform period of time. For example, every 3 hours you will add a certain volume of fresh medium. That means if you want to prolong the exponential phase for about 14 days, that means you need to add on the fresh medium every 3 hours. Okay, since we are adding the fresh medium, it is very important to us to ensure that the cell or the culture that has been inoculated into the tank is remain inside the tank even after we withdraw some of the volume from the previous medium, because if we cannot ensure that the cell is still remain inside the tank even after the withdrawal, we will have a problem to produce the optimum yield of the product. So how are we going to ensure that the cell is still remain inside the tank even during the withdrawal of previous medium? We are going to use cell immobilization. Cell immobilization is a process for us to trap the cell so that it will keep inside the medium. There are several types that we can use to ensure that the cell is remain inside the medium. We can use alginate beads so that the cell will attach and bind with the alginate. We also can link the cell with other material. We also can trap the cell inside an inert material such as a gel structure. And the last one, we can hold the cell in a permeable material. Basically, we will attach or we will combine the cell with an inert material. Inert material basically is insoluble material that will not dissolve inside the medium, and the material will hold the cell inside the medium. So when we attach the cell with the insoluble material, so that the cell will remain inside the tank even when the withdrawal process is occurred. Okay, each fermentation process consists of chemostat, whereby one nutrient will be limiting or control, and the chemostat will determine whether the nutrient is depleted or not. The reactor is continuously stirred, maintain a constant volume by incorporating an overflow weir or leveling device. The volume of fresh medium added is same as volume of medium introduced, and the cell growth is controlled by the availability of the rate-limiting nutrient. Besides that, continuous fermentation is not under dynamic state. Why there is not dynamic state under continuous fermentation? Because under continuous fermentation, we are controlling all the parameters. We are ensuring that the medium is keep adding to ensure that the cell will receive a fresh medium at uniform interval time. So whenever the cell receives a fresh medium at interval time, hence we can prolong the exponential phase. Besides that, we also will control the pH inside the medium tank. Hence, continuous fermentation will produce a stable and steady state of fermentation. Okay, why industrial do not keen to use continuous fermentation compared to batch fermentation? The first one, continuous fermentation is only meant for primary metabolite. Secondary metabolites are produced only during stationary phase. Continuous fermentation is not suitable if you want to have a secondary metabolite. It's only meant for primary metabolite. Maintenance of sterility is difficult because we want to prolong the exponential phase for a certain period of time, and we need to ensure that during the fermentation process, the equipment is under sterilization, sterile, without any contamination. And the last factor is high infrastructure cost is required. Okay, and now we move on to the third operating system for fermentation in industrial. We call as a fat batch fermentation. As we can see from the name of the operating system, fat batch is the adjustment or is the modification from batch fermentation. We can recall that batch fermentation is a closed system without any addition of new fresh medium. Under fat batch fermentation, we are adding the fresh medium inside the tank at interval time. However, the nutrient that we are add on inside the tank is not much as continuous fermentation. The medium that we are add on inside the tank is in a very minimum amount and very concentrated. That means for fat batch fermentation, there is no withdrawal will be occurred because the amount of nutrient that we are add on is not much compared to continuous fermentation. The medium is highly concentrated to avoid dilution. Nutrients are added in several doses to ensure there is not too much of nutrient present. Too much nutrient will inhibit growth over nutrient, and the medium is continuously or periodically added. Okay, that are the three operating systems that commonly used in the industrial. As a wrap-up, I want to recall all the main points from the three operating systems. The first one, there are three types of operating system that commonly used. The first one is batch fermentation, second one is continuous fermentation, and the third one is fat batch fermentation. For batch fermentation, is also known as a closed system because during the fermentation, there is no addition of new freshly medium or there is no adjustment towards the pH of the medium. The cells will undergo all the four growth phases starting from lag, log, stationary, and also desk. Batch fermentation is suitable for fermentation to produce a secondary metabolite. And under the lab phase, all the cells will undergo the adjustment period. There is no increasing in the number of cells, but they will increasing in the size of cell. There are a few factors that contributing on how we are going to shorten up the lag phase. Some of the factors are by using the same chemical composition and same carbon source as the previous medium, using the high concentration of cell, using only the viable cells, and also using the young inoculum. Once the cell already adjusted themselves to the new environment, the cell will entering the second phase we call as a log phase. Under the log phase, the cell will start to divide, the cell start to grow, and the cell start to use all the nutrients from the medium. In this phase, the metabolic rate is in the high rate, and it will start to produce the primary metabolites such as alcohol, such as amino acid, and so on. Okay, once the nutrient inside the medium starting to deplete, then the cell will start to die. Whenever the cells start to die, automatically the stationary phase will start. Under stationary phase, the number of cells is equivalent to the number of the dead cell. The nutrient starting to deplete and the accumulation of toxin also occurred. Besides that, the secondary metabolite also being produced under the stationary phase. And the last one, whenever the number of dead cells is higher compared to the live cell, then the dead cell will be started. Under the dead cell, the cell will undergo lysis process. For the second operating system, or the continuous fermentation, we also call as an open system, because during the fermentation, we are add on the freshly medium inside the fermentation tank to prolong the log phase. So the amount of freshly added medium is equivalent to the amount of medium that we're going to withdraw later. The reason why we need to withdraw the amount of medium, this is because to avoid overflow from the tank. And continuous fermentation is an operating system that's suitable for primary metabolite such as alcohol or amino acid, because the main objective for continuous fermentation is to prolong the log phase, and we can prolong the log phase as long as we desire. And the last one is fed batch fermentation. This is the modification from the batch fermentation. In comparison with continuous fermentation, fed batch fermentation will have the addition of freshly new medium, but in a very small doses and highly concentrated. The reason why we are using the highly concentrated medium, because we want to avoid dilution inside the medium. Okay, so this is for now, and we are going to continue in the next video.